All right, let's practice by doing another word problem. Here's example number 5. It says here a turbojet flies 50 miles per hour faster than a superprop plane. If a turbojet goes 2,000 miles in 3 hours less than it takes a superprop plane to go 2,800 miles, find the speed of each plane. Okay, we want to find the speed of the superprop plane and we want to find the speed of the turbojet. Okay, so those are the two things we're talking about, right? The turbojet plane and the superprop plane. So I'm going to start by kind of organizing my thoughts into the chart. So I have a turbo and a superprop plane. Okay, distance. Do we know the distance that either of these planes go? Well, it says here that the turbojet goes 2,000 miles. Isn't that a distance? While the superprop plane goes 2,800 miles. So it looks like those are the distances for both of my planes. Now let's talk about the speed. Well, that's actually our question, right? We need to figure out the speed of each of these planes. We don't really know the speed of each of these planes. But it does say that the turbojet flies 50 miles per hour faster than the superprop plane. We don't know what the superprop plane's speed is, so we can call that x. If the turbojet flies 50 miles per hour faster then what would I call the rate for the turboplane? Can I call that x plus 50? So there's my two variables, and when I go to solve for x, now we know that x is really the speed of the superprop plane. Once we figure out the speed of the superprop plane, we can add 50 to it and get the speed of the turbo plane. Okay, do we know the times? Well, it says here that the turbojet goes 2,000 miles in 3 hours less than it takes the superprop plane. So we don't really know their times, but we do know that it's less. We don't know the time of the superprop plane, but we do know the turbo plane takes 3 hours less than. So whatever the time is, minus 3 hours, right? So can I say t and t minus 3? But that's a lot of variables. We don't really want x's and t's in our problem. But we do know from before that time is really the distance divided by rate, right? So then I can say that. I can say that my time for the turbo, the t minus 3, is really equal to his distance over his rate. That's the 2,000 over x plus 50. And the time for the the superprop plane is t, which is equal to his distance over his rate, which is 2,800 over x. You notice that there's times. The t is the same in both of them, right? And we can use our ideas of solving a system or substitution by taking this t and plugging it in for this t. So then I actually get an equation that says that I have 2,800 over x minus 3 equals 2,000 over x plus 50, because I can take the time from the one and plug it into the time of the other. I can substitute in the 2,800 over x into the t of the other equation, because that's what t equals, right? Using my idea of substitution. So now I actually have put all of this information together. I now just have one variable, x's. I have this rational equation that I should be able to solve now. We've got a couple of fractions, all with different denominators. So the next step is to try to get common denominators so we can start to put all this stuff together and solve. All right, the first equation, my 28 over x, only has an x in its denominator. It still needs an x plus 50. So let's multiply that to the top and the bottom. The middle fraction, the 3, or can I say 3 over 1, only has a 1 in its denominator. So it needs both. It needs the x and the x plus 50. The last fraction has the x plus 50, but it needs the x on top and on bottom. All right. Now that every single fraction has an x and an x plus 50, they have common denominators. And so if their denominators are the same, then that means their numerators should be the same. And we can just focus on the numerators now in order to be able to solve this rational equation. So it looks like my top has a 2,800 times an x plus 50. It has a minus 3x times an x plus 50, and it's equal to 2,000 times x. I can go ahead and distribute to get rid of the parentheses. And it looks like I have some x squareds and x's, right? I have x's and I have x squareds, and so now I know that this is a quadratic equation, and now I can use my rules for quadratics. I can try to factor, I can try to complete the square, or I can use quadratic formula if I need to in order to solve for x, which remember is the speed of that super prop plane, and as soon as I know that, I can find the speed of the turbo plane. All right, here we go. Let's go ahead and combine the 2,800x and the negative 150x because they're on the same side of the equation. I put it in order a little bit where I put my negative 3x squared first, then I put my 2650x second, and then I put my positive 140,000, and that's equal to 2,000x. Because I have x squareds and x's, I want to move everybody to the same side. So I'm going to move that 2,000x over to the left side by subtracting it over. When I do that, it looks like I have a negative 3x squared plus 650x plus 140,000 equal to 0. I now have my quadratic in standard form. The only thing that I don't quite like is that negative 3 leading coefficient. You can keep it there if you're okay with it and work with a negative 3, that's fine. But for whatever reason, I'm more comfortable if that leading coefficient is positive. So I'm actually going to go through and divide every single term by negative 1. Remember, I'm allowed to do that as long as I make sure I divide every single term by negative 1, my equation should still be balanced. What that actually does is actually change my sign to everything. My 3x squared now is positive. I have a negative 650x, a negative 140,000 equal to 0. So now that I have that, it looks a little more comfortable to me with that leading coefficient being positive. From here, I can try to factor, but I don't know if there is a GCF, so I would have to try to bottoms up. 3 times 140,000 is going to be a really big number. I tried to work with it. I spent forever trying to figure out numbers that multiplied to that number that added to negative 650. It was taking me so long that I stopped doing that, and I thought, you know what? I can solve any quadratic equation by using quadratic formula. I should be able to pick out my A, my B, my C, plug it into the quadratic formula, and solve it that way instead of trying to figure out factors. So let's try that. In my quadratic equation now, my A is 3, my B is negative 650, and my C is negative 140,000. Now yes, these numbers are kind of big, but all I have to do is plug them into the formula and simplify using my calculator instead of trying to figure out factors of. So using my quadratic formula, I have negative B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. So now using my calculator, I can simplify a little bit. The 2 negatives in the front made me a positive 650. In my calculator, I can figure out what negative 650 times negative 650 is. That's going to give me a positive 422,500. Then I can figure out 4 times 3 times 140,000. It looks like these 2 negatives are going to give me a positive, so that's how the positive came to be. And I got 1,680,000. Doing it step by step in my calculator, I'm going to go ahead and add these two numbers together underneath my radical. Then, again, using my calculator, I can figure out what the square root, oops, I don't want to delete that, what the square root of, what is that number, 2,102,500 is, right? And it happens to be an even square root. So I actually have 650 plus or minus 1,450 over 6. So underneath that radical ended up being an even root. My radical is gone now, which really meant that I could have factored it at the beginning. You would have had to figure out numbers that work, but it could have been factored. But either way, we are still able to solve this equation using the quadratic formula if we couldn't have figured out how to factor. But let's keep going. Let's not leave the answer like this. Let's actually figure out what these numbers are so we can figure out the speed of these two planes. Remember, we're still solving that word problem, right? So I end up actually having two different answers. I have 650 plus 1,450 divided by 6, and I have 650 minus 1,450 divided by 6. I'm going to use my calculator, add those, divide by 6, and I got 350. I'm going to use my calculator, subtract those, divide by 6, and I got negative 133.33 repeating. Okay, so that means that x equals 350 and x equals negative 133 and a third. So let's go back to the word problem, finish this so we can figure out what the heck those numbers mean. Remember, x represented the speed of that superprop plane, and we were trying to find the speed of those planes, so as soon as I can find x, I know the speed of that superprop plane. So we're saying here, when we get an answer of x equals 350, that the superprop plane was going 350 miles per hour. That seems really fast, but I guess doable, right? It's also saying, though, when we get x equals negative 133, that this plane is going negative 133 miles per hour. Well, in that particular case, it doesn't really make sense to say negative for speed. So we get answers, two answers, because we have a quadratic. But because we're doing an application problem, we have to really just make sure that we're using the one that makes sense in the problem. So I'm going to just use the 350. So we know now that the superprop plane was going 350 miles per hour. Whew, pretty fast. What was the turbojet going then? Well, if the superprop plane was going 350, we should be able to figure out what the turbo plane was going by adding 50 more miles per hour to it because it goes faster. So I can say that the superprop plane was going 350 miles per hour and the turbo plane was going 400 miles per hour. Whew! Again, lots of different work on this problem, lots of different steps to take, which means, unfortunately, lots of different room for error. So you've got to be really careful. You might want to use the strategy of setting up that table with the distance, the rate, and the time, figuring out how they are all related so that you can set up an equation. Once you have that equation set up, you've got to be able to solve it by getting your common denominators. Once you get it to look like a quadratic, you then have to use your quadratic techniques. Are you able to square root, or can you factor, or do you have to use quadratic formula? Make sure that you practice one like that. We'll do an example or actually a try-it problem here in the next video. Maybe you can try it all by yourself and see how far you get to really make sure you understand.